right. Okay, so we are going on with chapter 3, and now we're going to do 3.4. So we're going to look at slope and rate of change, which it says slope and rate of change, but please keep in mind these things mean the exact same thing. Rate of change is just a fancy way of saying slope. So let's get a pen. All right. So the first part is just finding slope given 2 points. So you're going to have 2 different points. So you'll have an x1, y1, and an x2, y2. You're going to find the slope between those. In other words, you're going to look for the steepness or the flatness. All right, so the slope of a line between 2 points, x1, y1, x2, y2, is given by m is the variable that represents slope, which is your rise over your run. So you always want to do your y values, which is going to be your rise, over your x values, which will be your run. So the change in y divided by the change in x. So you take your 2 y values and you find the difference. Take your x values and find the difference. You do not want the x1 and the x2 to be the same number, because then it would be 0, and you can't divide by 0. So this is the formula for slope that you're going to need to know. All right, so we're going to find the slope of a line. Let me move this out of the way. So find the slope of a line through 4, -3, and 2, 2. And then we're going to graph the line. So if we let x1, y1 be 4, -3, x2, y2 be 2, 2. I'll tell you when I'm doing these, when they just give me 2 points, I don't ever write it like this. I just write it underneath. x1, y1, x2, y2. I write it underneath. It's just quicker and it's easier to look and see what's assigned to what. So you take your formula. So I'm going to rewrite the formula up here. So y2 minus y1 over x2 minus x1. So this is the formula for slope. So notice the y2, we assigned that to be 2. So that's where this 2 comes from. Minus, because the formula says to minus. And then y1 is -3. So now we have that -3. So when you have 2 negatives, what happens? Well, they turn into positives. That's where the 5 comes from. Then in your denominator, you have x2 minus x1. So x2 is 2, which is where this 2 comes from, minus, because the formula says to minus, and x1 is 4. So 2 minus 4 is -2. So now, if you rearranged it, if you did -3 minus 2 and 4 minus 2, so it doesn't matter if you do x2 minus x1 or y1 minus y2, as long as you are consistent. So if you're going to use y2 first, you have to use x2 first. If you want to use y1 first, you have to use x1 first. So both of these things are the same. So our slope is -5 over 2. All right, so since our slope is -5 over 2, so what I'm going to do is we plot the 2 points. So here is 2, 2, and here is 4, -3. And then you draw your line. So remember, this is your rise over your run. So if you think about it, your rise would be, and they say rise, but that you could go up or down, either one. So we're rising -5, and we're running 2. So down 5 over 2. Keep in mind that whatever point you choose, like I could have started at this point here, and you rise 5 and go backwards 2. So this would be a rise of +5 and backwards 2. But no matter what, you have a negative in there, which is going to make it point to the left. So when finding slope, it makes no difference which point is identified as x1, y1, and which is identified as x2, y2. Just remember that whatever y value is first in the numerator its corresponding x value is first in the denominator. So like I said, if you're going to use y1 first, you have to use x1 first in the denominator. So let's find the slope of a line that goes through negative 2, 1 and 3, 5. And then we're going to graph the line. So first off, assign your points, x1, y1, x2, y2. So now we know that y2 is 5, so if we plug those numbers in, so you're going to get 5 minus 1, and then you're going to do your x values. So now we have 3 minus negative 2. So we know what happens when there's two negatives. They're going to become positive. So 5 minus 1 is 4, and 3 plus 2 is 5. So our slope is to rise 4 and to run 5. So if we plot our 2 points, so we've got negative 2, 1, which we already have a point here, and then 3, and I need to move this, and 3, 5, which is here. And then if we draw our line, and it's really hard to draw on this, and make it straight. So there is our line and the slope of that line. So if I go to this point, if I go up and over, so you just go up until you're even and then go over. So we're going 1, 2, 3, 4. So we're rising 4. We're running 1, 2, 3, 4, 5. Running 5. Slope, rise 4, run 5. All right, move this back. So here's your choices. Slopes are either positive or negative. So if it points to the right, it is positive. And if it points to the left, it is negative. So if it's pointing to the left, and if it points to the right. And they're talking about the upper portion, pointing to the right or the left. Lines with positive slopes go upward, and lines with negative slope go downward. All right, so now we're going to find the slope of a line if they give us the equation. So slope-intercept form, this is super, super important. Okay, this is like one of the main concepts. Y equals mx plus b. So y equals the slope times x plus the y-intercept. Remember, your y-intercept is written in this format. So if you have this equation right here, you can tell what the slope is. It's 3. And please keep in mind, if your slope is 3, then the rise over run version would be rise 3, run 1, because 3 divided by 1 is 3. So this would be your rise over your run. And then your y-intercept is -4 because it says plus the y-intercept. So if it says minus, then that means plus -4. So this is the same thing as saying y is 3 over 1x plus -4. Obviously, we're not going to write that because that looks super messy. This is much more clean. The cool thing is now you don't have to do your tables and do the same problem 3 or 4 times and plot it. You can actually plot it from this information. So find the slope and y-intercept of this line. All right, so our slope is 5 over 9, and the y-intercept is 0, 3. So if we rewrite it in color, so whatever's in front of the x, I always remember M is for mountains, and mountains have slope. So M is for mountains, and mountains have slope. B is the number that's by itself. So if you have, I could have written y equals 4 minus 2x. Well, in this problem here, my slope is, let me slide this out of the way. My slope is -2 because the slope is the number that's with x. And you have to use the sign that's in front of it. B is your y-intercept. It's the number that is by itself. Oops. Hazards of working from the kitchen table. All right, so find the slope of this line. So notice this one is not in the form that we need it to be in. It has to be in this format. If it's not in this format, you cannot answer the question. So we have to get it in that format. So the first thing we do is we're going to move the x term to the other side. So you take your equation, and we're going to move the x term to the other side. So that means I am adding the 3x to both sides. So it cancels from here. Now I have 3x plus 11. And then the next thing you're going to have to do is divide. Oops. Then you're going to divide everything by 2. You have to divide everything by 2. So it cancels here. Now that gives me my slope, 3 over 2, and my y-intercept is now 11 over 2. So slope is 3 over 2. Y-intercept is 11 over 2. So here they're just asking for the slope, but make sure you know the difference between the two. Find the slope of the line. Negative y equals 6x minus 7. So we have to solve for y, not negative. So remember, if there's a negative in front of it, that means negative 1. So we're going to start with our equation, and then we're going to divide everything by negative 1, so that cancels. So we're left with y equals 6 divided by negative 1 is negative 6, and negative 7 divided by negative 1 is positive 7. So now we know that the slope of this line is negative 6. M is for mountains, and mountains have slope. All right, so now we're going to talk about horizontal and vertical lines. Remember, horizontal is your x values, vertical is the y values. So just a rundown, the slope of a horizontal line. The slope of a horizontal line is always 0. It will never change. Horizontal lines have a slope of 0. They're parallel to your x-axis. Do you remember before we left for spring break, and also I mentioned it in the last video about Vux Hoy. So this would be the Hoy version of this. Horizontal lines have a slope of 0, and their equation will be y equals some constant. Okay, so no matter what, the y value will always be the same because it all goes through whatever that y value is. All right, so knowing that, oops, so find the slope of y equals 3. All right, so y equals 3. Well, we know that if it's y equals, then we find the y-axis. We find the number 3 on the y-axis, 1, 2, 3. And you're going to draw a horizontal line through that number. This is y equals 3. Since it's horizontal, we know the slope is 0. So horizontal, slope of 0, y equals some number. So if we were to just use these points, because it says y is 3, so this is y. You plugged them in, 3 minus 3, 7 minus 2. You did the whole x1, y1 thing. x2, y2. 0 divided by 2 is 0, no matter what. So the slope of the line y equals 3 is 0. So if you see an equation that says y equals, the slope is always 0. Vertical lines, that's where the Vux that we talked about. Vertical lines have an unidentified slope. So vertical lines have an unidentified slope, and their equations are always x equals some constant. So anytime you see x equals, so if I use our same example of x equals 3 instead of y equals 3, so you go to the x-axis and you find 3, and you're going to draw a vertical line. It will be parallel to the y-axis. So this is x equals 3, and the slope is unidentified, or undefined, not unidentified, just undefined. So find the slope of this line. So since it's x equals, remember Vux, so x equals some number, that means your slope is undefined, and it is a vertical line. But if you were to assign it some points, so they're saying to use the points -2, 8, and -2, 6. So if you plug those in, x1, y1, so you got 8 minus 6 is 2. Negative 2 minus negative 2, which means they become positive. 2 plus 2 is 0. You cannot divide by 0, so therefore it is undefined. So the slope of a line, x equals negative 2, is undefined. All vertical lines are undefined. Now we're going to talk about parallel and perpendicular lines. So two lines that never intersect are called parallel. So parallel lines never intersect. They have the same slope. So that is the key part of parallel lines. If you think about like the bleachers at a stadium, you want them to have the same slope so that the bleachers are not crooked. So therefore they would be, all the bleachers, all the stairs would be parallel. Perpendicular lines, they intersect at right angles. It's important that they are right angles. So perpendicular lines make a right angle. Two non-vertical perpendicular lines, they have slopes that are negative reciprocals of each other. So for example, if you have one that has a slope of 2/3, then the perpendicular, and this is the symbol for perpendicular, by the way, let me go back here for just a second. This is the symbol for parallel, just like the lines. And then the symbol for perpendicular is an upside down T because they make a right angle. So a perpendicular slope would be -3/2. So negative means they're opposite of each other. One has to be positive and one has to be negative. And remember, reciprocal just means to flip it. So if 2 is in the top, then 2 will go to the bottom. So they're going to trade places and it's going to become negative. Same rule applies if you have a slope of, say, -5/7, then the perpendicular slope would be 7/-5, or sorry, +5. One has to be negative, one has to be positive. The 7 has nothing to do with positive or negative. You want the whole fraction to be positive or negative. So change their signs, change their position. So we're going to determine if 6x plus 2y equals 9 is parallel to -3 minus y equals 3. So the first thing you have to do is find the slope. So you have to get them in y equals mx plus b form in order to determine that. So I'm going to subtract 6x from both sides. So I get 2y equals -6x plus 9. Remember, you cannot put those together because they're unlike terms. And we're going to divide everything by 2. So y equals -6 divided by 2 is -3. And that's plus 9/2. I'm just going to leave it. And then this one has a slope, a slope of -3. And if you think about it, it's 3/1. This one here, I'm going to add 3x to both sides. So I get -y equals 3 plus 3x. And since that negative is there, that means I have to divide everything by -1. Y equals 3 divided by -1 is -3. 3 divided by -1 is -3x. This one also has a slope of -3. So since they have the same slope, then they are parallel. So your answer would be parallel in this case. So now we're going to decide if these two are perpendicular. Same thing, you have to get them in the form y equals mx plus b. So I'm going to subtract x from both sides. So 3y equals -15 minus x, almost missed that negative. And then you're going to divide every piece by 3. So y is -15 divided by 3 is -5. And that's a -1. So -1/3 x. So the slope of this equation is -1/3. Because remember, it's always the number in front of x. Your slope is always in front of x. This one here, I'm going to add 3x to both sides. So y is -1 plus 3x. Since y is by itself, I'm good. The number in front of x is 3, so this one has a slope of 3. So look at your two slopes. This is negative 1 over 3. This is positive 3. And if you think about it, this is really 3 over 1. So are they reciprocals? 1/3, 3 over 1? Yes, they're reciprocals. Is one negative and one positive? Yes. Therefore, these are perpendicular. All right, so now we're going to determine, are they parallel, perpendicular, or neither? So your lines can run parallel, your lines can be perpendicular, or maybe they just intersect. Okay, so you have three options. All right, so first thing you have to do, you have to get them in the format y equals mx plus b. So I'm going to do the first one here. So I've got negative 5x plus y equals negative 6. So I'm going to add 5x to both sides. So y equals negative 6 plus 5x. Since it says y equals, then I know the slope is 5, which means 5 over 1. Rise 5, run 1. I'm just going to look at it like this. I'm going to trade colors for a second. Actually, that one looked like it might write a little skinnier. All right, the other one is x plus 5y equals 5. So I'm going to subtract the x from both sides. So I get 5y equals 5 minus x. Now I have to divide every piece by 5. So y equals 5 divided by 5 is 1 minus 1 over 5x, because don't forget there's a 1 right there. So now this slope is negative 1 over 5. You have to use the sign that's in front. So now look at your two numbers. So are they opposites? One is positive, one is negative. Are they opposites and reciprocals? 5 over 1, flip it, 1 over 5. So these are indeed perpendicular to each other. So slope as rate of change. Rate of change, even though I said at the beginning it means the same thing as slope, you'll see it worded in word problems as rate of change and not the slope. So Becky decided to take a bike ride up a mountain trail. So think about a mountain trail, it's going to be going up. So obviously there's slope. The trail has a vertical rise of 90 feet for every 250 of horizontal. In percent, what is the grade of the trail? We don't really see anything about grade here in Texas because we don't have mountains. We might have some hills or whatever, but we really don't have mountains. But if you are in Colorado or somewhere that's mountainous, you'll see where there'll be signs that tell you the grade of the road. And what they're telling you is for every 250 feet you drive horizontal, there is a 90-degree rise. So your rise would be 90 and your run would be 250, meaning the steepness of the hill that you are going to be driving up. So the grade of a trail is given by rise over run. So the grade of the trail is 90 divided by 250, which is 0.36. But they're wanting, you're going to see it as a percent. They're not going to tell you the rise and the run. They're just going to say this road or this hill or this mountain has a 30%, 36% grade, meaning it's going to rise 90 feet for every 250 feet. Of course, you won't know that, but you'll at least know the steepness. Find the grade of this road. So this is your rise. This is your run. So we're looking for the grade. So rise over run would be 3 over 20. 3 over 20 is 0.15. 0.15 as a percent is 15%. So not a very steep grade at all. And that is it. So we'll do the last section and then we're done with chapter 3.